So now we're going to take a look at solving equations in section 2.2. First thing we need to know is a solution set, and a solution set is a set of numbers that make the statement true. So for example, I could ask you, is 2 a solution to 2 plus x equals 4? Well, the way I'm going to check that is I'm going to go and substitute this 2 in for the x and see, does it make the statement true? 2 plus 2 does equal 4, so that is true, so yes, it is a solution. Well, let's check and see, is 3 a solution? So I have 2 times x equals 10. Is 3 a solution to that? I'm going to substitute 3 in for the x. 2 times 3 equals 6. 6 does not equal 10, so no, that is not a solution. One thing I'm going to notice is that equivalent equations have the same solution set. So for example, x plus 2 equals 5 and 6 minus x equals 3. Those have the same solution set. 3 works for both of those. If I plugged 3 in here, that would give me 5, and if I plugged 3 in for x, that would give me 3 if I solved it. So these two equations are called equivalent equations. Now we are going to learn a property which you will be using a lot in this class, and that is called the addition property of equality. And basically what this property says is that if I have an equation, A equals B, and if I add C to the left side of the equation, I have to add C to the right side of the equation, and that keeps the equation balanced. That means those equations are still equal. So I can add something to one side, but I need to add it to the other side to keep it balanced. So an example of this would be, well, 2 equals 2. If I go 2 and I add 1 to it, hey, that's the same as going 2 and adding 1 to it. I added 1 to this side, I added 1 to this side. Look at that would mean 3 equals 3. So how do we use this to solve equations? Well, this is what we're going to do. When we solve equations, our goal is to get the variable by itself. So my goal is to get x all by itself. And to do that, I'm going to look and see, well, what's happening to this x? And right now what's happening to this x is that a 6 is being added to it. Well, I want to get rid of that 6 because a 6 is being added. If I get rid of that 6, then I'll have x all by itself on one side. And that is my goal. So if I look, I'm going to say, hey, well, 6 is being added to x. What is the opposite of adding 6? Well, the opposite of adding 6 would be to subtract 6. That's the inverse operation. So if I subtract 6 from this side, hey, look what happens on the left-hand side. 6 minus 6, I end up with 0, and I just get x by itself on the left-hand side. And that is my goal, to get the variable by itself. But I have to remember, if I do something to one side of the equation, I have to do it to the other side to keep it balanced. So I'm going to take 5 and subtract 6, and I end up with a negative 1. Hey, it turns out x equals negative 1. That's going to be my answer. I can check that answer by going and substituting it back into the equation. So I have negative 1 plus 6. That gives me a 5. So let's take a look at some more examples. So this says solve for x. So here I have negative x plus 2 plus 2x equals 7 plus 5. Well, before I start figuring out getting x by itself, I notice I can combine some like terms here. So I'm going to go ahead and combine like terms. So I have a negative x plus 2x. That gives me an x. So on this side, I'm left with x plus 2 equals, well, I can combine that 7 and 5, and that gives me 12. So I now have x plus 2 equals 12. Again, my goal, get x by itself. What's happening to x? A 2 is being added. I'm going to do the opposite function, so I'm going to subtract a 2. Subtract a 2 from this side. Then I also have to subtract a 2 from the other side of the equation. So I'm left with x on the left-hand side, and 12 minus 2 gives me 10. I can check my solution by plugging it back into the original equation, solving it out, and I will see that it works. So here is another example, and what I notice in this problem is that, hey, I have the distributive property. So I'm going to need to do that distributive property first. So I'm going to go 4 times 2a, that gives me 8a, and 4 times negative 3 will give me a negative 12. I have my negative 7a equals 2 minus 5. Well, 2 minus 5 gives me a negative 3. Now I can combine like terms on the left-hand side, so I have 8a minus 7a, that gives me 1a. Minus 12 equals a negative 3. Now my goal is to get the variable by itself, so I notice that a is a negative 12 is being subtracted here, so the opposite of a negative 12 is adding 12. So if I go negative 12 plus 12, those are going to cancel out, and I'll be left with an A on the left-hand side. But if I add 12 to the left-hand side, I have to add 12 to the right-hand side of the equation, and negative 3 plus 12 gives me a 9. So A equals 9 is my solution. I can check my answer by plugging it back in, and lo and behold, I see it comes down to negative 3 equals negative 3. That means it works. Here's another example, 7y minus 6 parentheses y minus 1 parentheses plus 3 equals 9. So what I notice again, I'm going to have to do distributive property first, and I see, hey, this negative 6, I need to use that distributive property right here. So I'm going to have 7y minus 6, because negative 6 times y gives me a negative 6, and then I have a negative 6 times a negative 1, and that gives me a positive 6, plus 3 equals 9. Well, 7y minus 6y leaves me with 1y, and 6 plus 3 equals a positive 9, so that was combining like terms. I'm going to subtract 9 from both sides, and I'm left with y equals 0. Now this time we're going to look at a problem that has x's on both sides of the equation. And I say, okay, well, what do I do now? Well, what I'm going to do is I'm going to move these x's to the other side. So I'm going to start by moving the 2x. And to do that, that means I need to subtract 2x from the right-hand side of the equation. And when I do that, I'll be left with a 7 on the right-hand side. But if I subtract a 2x from the right-hand side, I have to subtract 2x from the left-hand side. And I'm going to make sure that I line it up with combining the like terms. I can't subtract 2x from 5 because those are not like terms. I have to subtract 2x from the 3x. So 3x minus 2x leaves me with 1x. I still have my negative 5 equals 7. Well, my goal is still to get x by itself, so here I was subtracting 5. I'm going to add 5 to get rid of it on the left-hand side of the equation, so then I need to add 5 to the right-hand side of the equation. When I do that, those will cancel out. I'm left with 1x equals 7 plus 5 gives me 12. So one question that you might have is, hey, what if I decided to move the x's to the other side? So in this case, I subtracted 3x from this side, and then I subtracted 3x from this side. On my left-hand side, I'm left with a negative 5, and on my right-hand side, I have 2x minus 3x leaves me with a negative x, and that's the same as saying negative 1x, and then plus 7. Well, I still need to get x by itself, so I'm going to subtract 7 from here, because that's the opposite of adding 7, but if I subtract 7 from the right-hand side, I have to subtract 7 from the left-hand side. Negative 5 minus 7 gives me a negative 12, and then that was equal to a negative 1x. Well, I don't want negative x, I want a positive x. So this is really saying negative 1 times x. And I want to do the opposite of what's happening to x. So if a negative 1 is being multiplied to x, the opposite of multiplying a negative 1 is dividing by a negative 1. So if I divide this side by a negative 1, those cancel out, and I'm just left with my x. But if I divide by a negative 1 on the right-hand side, I have to divide by a negative 1 on the left-hand side. A negative 12 divided by a negative 1 is just a positive 12.